Hey guys. Oh, you here to learn some math? Well, I guess I can put my phone away and teach you a little bit of math. Might as well, right? I just like being by myself for a little bit sometimes. In isolation. Nobody likes to be in isolation. Anyway. Well, we're going to have to do a little bit of isolation today. We're going to have to isolate the absolute value. So, starting out, this is actually section 1-4. But we're going to go ahead and work on it now. So, it's all about, this whole unit's going to be on absolute value. So, remember absolute value, of course, is these little bars you put around something. It doesn't have to just be x, we're going to see. In this case, yeah, just absolute value of x is 7. What would be the possible values of x? So, in other words, what values can I put in here to get a result of positive 7? So, the results, of course, would be, we can put in a regular old 7, right? Absolute value of 7. If we drop the negative, well, there's no negative to drop, equals 7. And the other answer is negative 7. We could plug in a negative 7, and the absolute value takes away the negative, making it positive, equal to positive 7. Okay? Hopefully that's a review for you. What about this example? What would the absolute value of x equal negative 4? What would x be able to be to come out to be negative 4? What are the possible values? 4? Negative 4? Nope. This little negative right here is throwing us off. Again, the absolute value drops the negative, so that we can't result in a negative answer, negative 4, if we're always getting rid of the negative. So this one's kind of tricky, and we got to pay attention to this stuff. This is going to be some stuff you probably are not used to seeing. So there are no values of x in that case. Okay. So here are the steps to manually, by hand, do your steps to solve your absolute value equations. This is important to note. It's not like your regular old equations. You know, you can do those without even really thinking about it. But not the absolute value ones, okay? There's some steps you got to remember to do these by hand. So we're going to, first step is to isolate the absolute value expression. So wherever your absolute value signs are, you're going to get them by themselves. So you're going to move everything to the other side of the equals. Then we're going to create two cases. One case where it's equal to the positive value, and then another case where it's equal to the negative value. Okay, and you'll see that in a sec. Then we solve for both equations. So the one equation splits into two. We solve for both, and then we check for extraneous solutions. And what are extraneous solutions? So this is probably new as well. Let's get a color that highlights a little bit better than the yellow. Yeah, that's a little bit better. Alright, so we are going to, let's put the text box here. Yeah. Alright. Extraneous solutions are solutions. Well, if they're extraneous, what does that sound like? Extreme. Solutions that do not work in the original equation. They typically do not come out when we're solving the original equation, but they're still solutions. So this is going to be a new concept, most likely for most of you in this class. Alright, this doesn't happen too often, but it does happen. So, solve each equation. Be sure to check for extraneous solutions. Alright. So to start out, we're going to start with this example, x minus 9 equals 5. Alright, now this example is nice and easy because the absolute value is already isolated, so we don't have to worry about step 1. But we do create the two cases. So this absolute value can be positive and be equal to 5. It can also be negative and equal to negative 5. So this is how I split it up. So we drop the absolute value, and we just solve it like normal. Oh. That is not a Z. And then, so that's case 1. And then case 2. is where this result can also be negative 5. So x minus 9 equals negative 5. And some people do this. They put the negative in front of the x minus 9, but I think it's, I don't know. I'm used to saying this can be positive or it can be negative, so that's how I do it. It really doesn't matter. Nah, it doesn't matter. Okay, now we're going to solve for each of these. So add 9 to this side. That would equal to 14. This side, add 9. So the nice thing is you're just doing, the problem with the other way is you'd have to distribute the negative if you started over here. And it's like, who wants to start with distributive if we don't have to? Just move the 9 over there. Yeah, just my 2 cents. All right, negative 5 plus 9 is 4. Yeah, it is 4. And then, so therefore, we're saying that the two solutions are 4 and 14. Let's go ahead and see what this looks like on graph. So go ahead and get Desmos open or your calculator out. I'll go ahead and start with Desmos. Where you can see absolute value, you can pull up the keyboard right here, and absolute value is right here. And also on your Chromebook keyboard, if you look on the right side above the Enter key, you can do Shift and then push that key, and it'll give you this. It'll give you a straight bar. So that's, again, above the Enter key on your Chromebook, but push Shift. Also, this will work as well. So it brings up your absolute value bars, and then type in x minus 9. Push the arrow over to show you're done with the absolute value, equals 5. So we're just typing it in, how we see it. And, oh, my graph's a little bit. So here we go. 4 and, what was the other answer? 14. There we go. So what you will see is, if there are 2 answers, 2 lines going through your 2 answers, 4 and 14. Woohoo! Yeah! There we go. So there are no extraneous solutions for this one. We don't have to worry about that. Obviously, it's just those 2 negative answers. So, that's it for that one. Alright, I'll let you do this one later. We're going to practice. I'm going to do a few with you together, and then I'll let you practice the others after a certain time. Let's see. Let's look at number 6. Okay, number 6. Absolute value is not isolated. We got to isolate it. We got to put it in quarantine. So we have 3 right out here, which is messing everything up. So to isolate it, we would do the opposite. What operation is happening here? 3 times. So the opposite would be to divide. So we would want to divide both of these sides by 3, giving us n plus 8 equals 39 divided by 3 is 13. Okay, so that's step 1, isolating our absolute value expression. Next, we're going to do the split. So m plus 8 is equal to 13. We'll solve that, and then m plus 8 is equal to negative 13. Ooh. Okay, so go ahead and solve for both of those. M is equal to 5. And m is equal to negative 21. Put your answers least to greatest. So least is negative 21, comma 5. So I forgot to say the handheld calculator. Sorry about that. So to get absolute value on here, you would push math, and then arrow over once to the right under number, NUM, like this. And number 1 is absolute value. You just push enter, and then you have your absolute value ready to go. So that's how you would do it in this calculator. But I'm going to be mostly showing Desmos, but I will do my best to remember to show you on that calculator as well. Let's go ahead and do this one in Desmos. So I'm going to change the previous one. That's to 3. All right, now one thing. If you type in M, usually it freaks out and it shows you nothing. It gives you this little triangle. Let me change this to +8. 3 and +8 equals 39. Okay, so yeah, it brings up this triangle. Now the reason it brings up the triangle is one simple reason. It does not read M as a variable. Desmos is programmed to want X as your first variable, and then yeah, you can put in a Y, but you'd have to go in order X, Y, Z. Those are the only variables that it likes. So keep that in mind. That can be tricky when graphing answers. Is if the problem gives you a different variable, you have to remember to type in X instead. So 3, absolute value, X plus 8, 39, and our two answers were what? -21 and 5. There's 5. And there is 21. Yep. Alrighty. So far, so good. Okay, let's do number 7. I'm going to do that one. This one, a little bit different. Okay, so to start out, we got to isolate the absolute value. So again, we divide by 16. Those will go away. Absolute value of r minus 5 is equal to -32 divided by 16 is -2. Okay. This is where you have to have your alert on, okay? You got a little flag should go off in your head saying, wrong, anytime you get a negative here. After isolating the absolute value, that's a bad sign. So there is no possible number that you could put in, so the answer right away is none or no solution. Okay, let's see what happens when we put this in Desmos. So value of X minus 5. And I'm just putting in after my, well, I guess maybe I should put in the whole thing. Let's see what happens when I put in the original. 16, absolute value of X minus 5 equals -32. Okay, let's see what it does for us. So, what I'm just doing is zooming out just to make sure I don't see any lines. And yeah, I see nothing. So, clear indication that it's no solution, and most likely you would put it in the graph first, and then you could do the work and start doing the work and then see, oh yeah, it's a negative, yeah, there's going to be no solution. So anyway, alright, so far so good. Let's see if we got some on the next page. Let's look at 14. Look at that. Okay, so this is an interesting one because we have X or H in multiple places. Okay, as opposed to all of them up to, I guess, number 12. So this is a case in absolute value where you're going to have to check your answers back into the original equation just to be sure. So we're going to first isolate the absolute value. Divide by 2. H plus 8 is equal to 7H. Alright, now we're going to do our two cases. H plus 8 is equal to positive 7H. And then H plus 8 is equal to negative 7H. Right. Move the H because we want to combine like terms. So this is a case like it'll start here, number 13. You got X here, so you're going to have to get those together. So that'd be 8 is equal to 6. H divided by 6. H is equal to, let's simplify that, that's 4/3. Alright, And then here, minus h, h is equal to negative 8h divided by negative 8. And h is equal to negative 1. Alright, so on these ones we need to go back in and make sure that they work. Okay, I'll just go ahead and do these in the calculator. So if it's 4/3, alright, I already typed it in, 2x plus 8 is, yeah. So 4/3. Now, this is what it looks like when it graphs. So when it graphs, even though we got two answers, it's showing only one line, and clearly it's showing the answer that is between 1 and 1.5, and that is this answer right here. This is really 1.3 repeating. So keep that in mind when you get repeating decimals like that. See how it keeps showing up in the middle of decimals and stuff? It's like, oh, well, it's getting close to 1.3. That's got to be 1.3 repeating. Okay. So there's that one answer. Notice how negative 1, however, does not show up as an answer. That means it's an extraneous solution. So it doesn't work when you plug it in. To see what I mean, I'm just going to put in 4/3 here, 4/3 there, and 4/3 there. But I guess Desmos doesn't really show that. Well, I guess you'd really just have to do this in the regular calculator. But anyway, the two sides would not be equal. So 2 absolute value of 4/3 plus 8, and then 14 times 4/3 is the same thing. So when you plug in one answer, you get equal sides of the equation like that. If you plug in negative 1, now that one I can do in my head. I was like, I was worried I wouldn't be doing. Alright, let's do this one. Here, 2 absolute value of negative 1 plus 8 equals 14 times negative 1. So I just did this. I plugged in this one in the calculator. Now I'm plugging in this one, but it's going to be easier to just do it by hand. So 2 absolute value of negative 1 plus 8 is 7 equals, that's negative 14, and you get positive 14 is equal to negative 14. So this is why that this doesn't work. So this answer right here is an example of extraneous solution. So we don't want it. We're not going to include that answer. So the only answer for number 14 is that h is equal to 4/3. Okay. So yeah, there you go. And that will happen in absolute value sometimes. If it looks like a lot of crazy stuff is going on, then you probably need to plug those values in just to see what happens. But good thing is Desmos is pretty good about not showing you those solutions, so you should be good with those. Alright, I think that's good for this section. I mean, that's about it. So why don't you pause the video and try as many of the rest of these as you can, and then press play when you are ready to see the answers. Alrighty, here we go. Number 4, negative 5 and negative 2. Number 5, negative 5 and 7. Number 8, negative 2 and 22. Number 9, 2 and 14. Number 10 is negative 4. Yes, sometimes they only have one solution. 11 is negative 16 and negative 4. 12 is negative 10 and positive 10. 13 is negative 2 and 5. And 15 is 3/4. And 16 is negative 9 and negative 11/5. Okay, well, I guess that'll take us into the next section. See you in the next video.